We will continue with exercises 8. Prove that if x, y, z are real numbers with z positive, then x squared plus y squared plus 12z squared plus 1 divided by 4z is greater than or equal to x plus y plus 1. Well, the given inequality is the same as is equivalent to x squared plus y squared plus 12z squared plus 1 is greater than or equal to 4z times x plus y plus 1. We can do this because it is given that z is positive. Due to positivity, we can multiply both sides of inequality by 4z since it is positive, and we have the same inequality symbol. So this is equivalent to given inequality. Well, if we separate this 12z squared, if we write this as x squared plus 4z squared plus y squared plus 4z squared plus 1 plus 4z squared. Well, for these two terms, if we group them like this, and if we apply here AMGM inequality, well, the first term is greater than or equal to this, the first one, x squared plus 4z squared is greater than or equal to 2 times square root of x squared times 4z squared, and the second one is greater than 2 times square root of y squared times 4z squared, plus the third one is greater than or equal to 2 times square root of 1 times 4z squared. Well, this actually gives the right hand side. So left hand side is greater than or equal to right hand side, and we are done. Well, by the way, in the problem, x, y, z are not given to be positive. So here, if we apply AMGM inequality, in these terms, we need positivity. But don't worry, anyway, x squared plus x squared plus 4z squared is anyway greater than or equal to 4xz, because this is, if you take this to the left side, it gives you x minus 2z perfect squared, which is definitely greater than or equal to 0. This is true all the time, so we have this inequality. So for negative, positives doesn't matter. For x, y, z, for x, y, we have this inequality. So this is okay. In the 9th exercise, we are supposed to prove that 3a plus b plus c perfect square is greater than or equal to 12a times b plus c for any ABC real numbers. Well, here we have an inequality x plus y perfect squared is greater than or equal to 4xy for any xy. This is very easy to prove. Well, this is, x squared plus 2xy plus y squared minus 4xy is greater than or equal to 0. Well, this is the same as this inequality. So that is x minus y perfect squared. Since it is a perfect square, it is always non-negative. So for any xy in real numbers, since this inequality is true for every x, y in reals, so if you choose this 3a to be x and b plus c to be y, now we have 3a plus b plus c perfect squared is greater than or equal to 4 times 3a times b plus c, which is 12a times b plus c. So by using this fact, we prove this inequality very simply. solve exercise 10, remember the inequality that we solved previously. X squared plus y squared plus z squared is greater than or equal to xy plus yz plus zx. Well, this inequality is true for any x, y, z, but here we are given positivity in the inequality. X, y, z are positive. Then prove that 1 over square root of xy plus 1 over square root of yz plus 1 over square root of zx is less than or equal to 1 over x plus 1 over y plus 1 over z. Well, here remember the technique that we used in proving this inequality, this given inequality, the one that we did previously. If we apply AMGM inequality 2 by 2 for these terms, 1 over x plus 1 over y is greater than or equal to 2 times square root of 1 over x times 1 over y. So that is 2 over square root of xy. Do the same thing for 1 over y plus 1 over z, and this is greater than or equal to 2 over yz, and 1 over z plus 1 over x is greater than or equal to 2 over zx. If you add them up side by side, these inequalities, so we get that 1 over x twice 1 over x plus 1 over y plus 1 over z is greater than or equal to twice again 1 over square root of xy plus 1 over square root of yz 1 over square root of zx. If we simplify the twos, we get the desired inequality. Well, this was A. Well, in the other ones we can apply the similar tricks. Do the same thing for B. Apply AMGM inequality 2 by 2 and we get the result. The third one is the same. The fourth one we'll do this maybe 2 times, maybe 3 times. Okay, let me not solve them.